So now I want to turn it over to Peter Axelson to talk about assistive technology for air travel. And Mr. Axelson is the president of Beneficial Designs, Inc., and as I mentioned earlier, a PDA member. He has a BS in mechanical engineering and a product design and an MSME in smart product design from Stanford University. And he has been working with PDA for a number of years, as well as his own company. And Beneficial Designs has played a major role in the coordination and development of national and international wheelchair standards. So now I'm going to turn it over to Peter, and you're going to see firsthand all of the great work that Peter is able to do. So Peter.
Thank you, Heather. So I'm going to first to let everybody know that what I'm going to start out with here is some review of some research that we conducted at Beneficial Designs. Beneficial Designs is a wheelchair test lab, and we conduct research in the area of assistive technology. And we received a grant award from the PVA's Research Foundation. And I am a PVA member myself and a wheelchair user for 45 years. We had studies, participants in this study, 24 of them, male and female, manual and powered wheelchair users, to try and identify what some of the issues are with air travel, and we did testing on boarding chairs as well. So I'm going to talk about these issues. I'm going to skim over them pretty quickly. The order of priority of these issues is, you're going to see why I prioritize them in this way: narrow aircraft aisles, the lack of accessible lavatories, steep jetway slopes, damage to mobility devices, dangerous transfer methods, unstable boarding devices, hazardous sitting pressures, and unusable onboard wheelchairs. And I'm going to present some potential solutions related to each of these issues. So the first is the narrow aircraft aisles. And the reality is that the aircraft aisle width never considered the fact that a passenger might have to board an aircraft in a sitting position. So I'm going to mention that the FAA created a standard in 1954 that the aisle width should be 20 inches, but that 20 inches would only apply at a height above the armrests in the cabin. So, and then below that 25-inch height, because they presumed that only legs would need to be walking down in that area, would be 15 inches for minimum width. And quite innocently, I think the FAA never anticipated that people might be entering the aircraft in a seated position. And so I'm going to show an illustration here that shows the front view of the cabin, that how the width ends up being 15 inches down real low, and how that width ends up being 20 inches up higher, where just the seat backs are located basically. So in the next image, I show how a person, a full 95th percentile adult male, what this looks like when that person is walking down the aisle, when there's a 15-inch aisle down in the low area where the knees and the feet up to the thighs are coming, and then above that height is where that person's hips and shoulders and body is moving through that 20-inch space. And so you could imagine how, when we think about just a walking ambulatory person, how that works for somebody that's walking down an aisle, but then when somebody goes to sit in a position, that doesn't work. So here's what ends up occurring is that a boarding device has to be made that's 13 or 13 and a half inches to be able to fit down that 15-inch space with some clearance to roll down that aisle. And then when you try and put a person into that, here we see that same boarding chair from the front view, showing that 13 inches down where the person's sitting, the 15-inch width, and then the 20-inch width up above the armrest. So now when we put that aisle into the aircraft, this is what it actually looks like, sitting in that 15-inch aisle width. And then when we have a person in that that boarding chair from the top view here, you see those red areas on the side is where the hips of that person sitting in that narrow boarding device, hanging off the sides of that boarding device, are going to actually scrape and get scraped along that 15-inch width. And so this is where the person sitting in that boarding device is at risk and at harm there, getting scraped on the seats as they go down the aisle. And in fact, we discovered in our survey out of 315 boarding device users that basically 5% of them had received bruises, scrapes, cuts to their legs, knees, hips, arms, and buttocks, tailbones being rammed through this space that's smaller than the passenger actually is. So that's a problem. So the major issue is the steep jetway slopes. The airport terminals are really high, so trucks can get clearance beneath the buildings to get baggage and whatnot in and out from underneath the airport. And so then the jetway has to be steeper to be able to go down to the aircraft. And so this is what it looks like going down the jetway. I'm actually doing a wheelie because it's so steep that I would tip forward out of my chair. Some people have to be backed down the jetways because it's so steep. And then there's even steeper sections between the sections of the jetway. This is a side view of a jetway showing this one's measured to be about 6 degrees. So this one's actually not that steep, but it is, again, even steeper than a standard ramp, which is about 4.8 degrees. And it's steep all the way to the door of the aircraft, you can see. And then if we look closer at this injury data as a result of this steep jetway, is that basically 12% of all passengers that are non-ambulatory have fallen over in a boarding device, and another 10% of those people have fallen out of the boarding device. So that you've got a 22% chance of falling over or falling out of the boarding device because the jetway is so steep and you're sitting in a boarding device that's extremely narrow. So this is what these boarding devices look like when we set them on our tilt platform in our wheelchair test lab. We've got them loaded with test dummies, and we're looking at 2 common boarding devices on the left there, and then an overhead lift type of boarding device called the Eagle. And you can see they're at their tipping angles. That's not that steep. The one on the left is only at about 7 degrees, where it's actually tipping over in that test there. And again, here is what the boarding bridge looks like right near the aircraft. It's at that steep slope as well. And so what happens is if that person's sitting in that boarding device, sitting laterally on that slope, and the attendant lets go of that boarding device, then that person actually tumbles over onto the ground. And this is an illustration of what it looks like to actually fall over in that boarding device. And again, I indicated that 12% of all non-ambulatory passengers that use have to use the boarding devices to board because they're non-ambulatory have fallen over in those boarding devices. So one of the issues is that you can see this is a top view of the passenger boarding bridge, the jetway coming down from up above, and then the aircraft over to the right. And so that the reason that assistant, the handlers that operate those boarding devices point that boarding device laterally is they want to just back up straight into the aircraft. So if I transfer, if you see that person in the wheelchair transfers to that boarding device, it wants to tip over in that downhill direction toward the bottom of the illustration. And that's just because that's the convenience of getting on in that direction is going to allow that handler, that assistant, to back that person into the aircraft. So my recommendation and our recommendation from PVA is that you insist that boarding device be pointed uphill, up the jetway, so that when you transfer onto that boarding device, you're not going to be as prone to tipping over laterally. That handler is still going to have to turn that boarding device and back you up toward the door of the aircraft, but they're going to be holding on to that boarding device, hopefully, while you're doing that part of the boarding process. So the steep jetways, the solution to that is to always point the boarding device uphill during the transfer, always insist that the handler is holding onto the boarding device. And then another longer term solution is to make the jetway level at the end of the jetway. And so the technologies exist to be able to, have the floor of that jetway adjust, or have the jetway be level at the end, and then have the slope down to the jetway be sloped, but allow for a level area to exist in the jetway. So again, the solution of creating that aisle width to be 20 inches all the way to the ground instead of just down to the armrest would drive a great solution, because then boarding devices could be 18 inches wide. And if a boarding device was 18 inches wide instead of 13 inches wide, boarding devices would not be so unstable. And this would allow for greater safety in boarding the aircraft, because right now those boarding devices have to be really super narrow to fit into 15-inch aisles. And if we moved toward aircraft being laid out with 20 inches clear down to the floor, that would change the situation. Most single aisle aircraft, the 737s, are all a full 18 inches wide on the aisle, not 20, but 18. So in theory, a boarding device could be 16 inches wide, but the 20 inches, the 18-inch wide aisle just still does not provide adequate clearance for people's hips to fit down that aisle to their seats. So 20 inches down to the floor is what we need in the aircraft aisle. Another possible solution is some air carriers provide access into the bulkhead seating to where you can transfer directly from your wheelchair into the bulkhead seating. Particularly, I think this is a Southwest flight where the armrest actually lifts up and the passenger can transfer right into the bulkhead seats without having to go through the transfer into a boarding device. However, many carriers have fixed armrest up in the front row of seating, and that makes it difficult to transfer into those seats at the front of the aircraft, and makes it difficult to get a wheelchair actually down into that position. Another possible solution, and this is a solution that I employ, is I sit in a super narrow wheelchair. I sit in a 15-inch wheelchair when I should actually be in a 16-inch wheelchair. I have fixed rigid skirt guards on the side, and you can see my pants trying to hang over the side of the chair there. I have an extra set of wheels in the back of my chair, so I can pop off my main wheels in the galley of the aircraft, and then I can maneuver myself down the aisle of the aircraft to the seat that I'm going to be seated in. So if the person is not able to fit to their seat and they have to ride in a boarding device, this procedure is often what's employed, is two handlers lift the passenger from the boarding device into the aircraft seat over the arm support. In this case, there's a fixed arm support and it does not fold up out of the way. It's a bulkhead seat. And the handler in this case on the left is actually one of the pilots, it looks like, the first officer or the second officer. And then there's what appears to be a flight attendant on the right. Now, in theory, these people shouldn't have to be lifting more than 50 pounds of weight. And so if that passenger is less than 100 pounds of weight, then it's reasonably safe for those handlers to lift that person into the aircraft seat. You see their seat cushion in place on the aircraft seat. But most passengers are not less than 100 pounds, like this passenger is viewed there. And so here we can see a passenger that's definitely over 100 pounds of weight. And you see these service providers trying to, they're going to lift this person, one in the back behind the wheelchair and one at the legs to lift that passenger onto the boarding device. This is setting up those handlers for an injury, and it's setting up the passenger in the wheelchair for an injury because people shouldn't be lifting people that heavy. In our survey of 121 people that are dependent on a two-person lift for transfer when traveling, 28 or 23% of them have fallen or been dropped. So this is literally a quarter of everybody that's dependent on people for those transfers. They've been dropped or they've fallen during this transfer process. And this is because some of these people are often untrained and they're just trying to lift somebody that's not capable of lifting or transferring somebody that weighs that much. And they often get drugged across into the seat. So there is a solution to this. There are boarding devices that will actually lift the passenger from their wheelchair using a sling that can be slid underneath the passenger. They pull their wheelchair into this device. It's called the Eagle. This device can be has an outrigger, so it's more stable in the steeper jetway area, and then it can go up and down and adjust in length. And so it adjusts to a narrow position for going down the aisle of the aircraft. You'll notice that the passenger is also lifted way up above the armrests of the chairs. So because it's battery powered and has a lift in it, it can lift the person up to clear up into that 20-inch wide area to go down the aisle of the aircraft. When it gets to the seat that the passenger is sitting in, it actually lengthens to the pitch of the seating, and then it moves laterally over the seats to adjust the person to be able to get in the seat. And then that person is lowered down into the aircraft seat. Once that person's in the aircraft seat, then the Eagle device moves back off the aircraft and the sling is slid out from underneath the passenger. So the potential solution is to require the use of these technologies that do not require physical lifting of a non-ambulatory passenger that's not able to independently transfer in and out of the aircraft seating. This would offer a more safe transfer with respect and dignity when this is done during a pre-boarding process. And that would actually suggest that, fundraising efforts could occur to provide these gantry-style lifts for non-ambulatory passengers who are unable to independently transfer into an aircraft seat. This technology was developed by Qantas Airlines in Australia, interesting. Another problem with boarding devices is seating on them is extremely hard. Showing in this illustration is a pressure map showing the red pressures, that these pressures are basically over 200 milligrams of millimeters of mercury pressure. And this is just not safe for sitting on any amount of time. And even with a cushion, the pressures can be high on the boarding devices. This is the typical sitting pressure of someone sitting on a pressure relief cushion. This is me sitting on a Rojo cushion that I typically sit on that has the adjustable air chambers. But if I sit on an aircraft seat without a pressure relief cushion, these are the pressures that I actually experience sitting on an airline seat. And so therefore I sit on my actual, not my Rojo cushion because it's affected by air, but I sit on a foam, custom contoured foam cushion. And you can see I'm elevated on that aircraft seat because of that extra cushion. My feet are dangling off the ground, so this causes constriction of the blood flow in my legs when this is happening. The arm at sports pushing forward on my shoulders when I'm doing this. So I carry a inflatable back support, a neck support, a head support. I use my backpack as a foot support. So then when I'm sitting, then I'm properly supported and comfortable and don't get the swelling in my legs with this extra pieces I carry along. There are also additional spine supports that can be attached to aircraft seating. And of course, the lavatory, which has been discussed by Lee and Heather, not being accessible, getting into them. There are lavatory designs where the walls of the lavatory morph into a single bathroom to provide greater access so that there's more room to actually get in there and in an onboard aircraft aisle. Finally, we come to the examples of the damage. You can see this powered wheelchair, the main drive wheel is actually broken off this chair. All sorts of other damage occurred at electrical systems and the housings and the shrouds, the caster assemblies get bent. And this is the reason is that wheelchairs often have to be tipped on their sides to fit through the baggage doors because they're too short and wide, and the joysticks get damaged on the aircraft. And a lot of people basically no longer fly because of the damage to their chairs. In our survey, out of 543 respondents, people either had their wheelchair damaged, it was actually lost or misplaced during the travel. And so a total of 71% people, travelers have had their mobility device mishandled during travel. So if you have a folding onboard wheelchair, it can generally be folded into place. And I suggest using an elastic strap to strap that chair together. And this can be slipped into the closet area on board the aircraft for stowage during the pre-boarding process. And to handle the damage issues when they get sent down below, resin is written in Assistive Technology for Air Travel Standard. And the idea is that this addresses all the issues related to mobility devices in travel.